In this session of DezignWorks TV, we're going to be reverse engineering an impeller blade using DezignWorks with SolidWorks. So we're first going to create an alignment, and we're going to take at least 3 points to actually define a base plane. You can take more. They're going to be defining an X location, a Y, and in this case, we're going to do the origin as a circle, which matches the OD of the impeller. And notice most of the commands we're doing are being driven from the arm. It's DezignWorks new heads-up display. So once we do this, we're just going to capture the OD of this. So we're going to use the DezignWorks circle tool and take at least 3 points. You can take more than 3, or you can even drag it. So we're capturing the OD of this, because our goal is to capture the OD, and then what we'll do, we'll use the lock plane tool to capture the profile, and then we'll revolve it. So we're going to exit to sketch, and we're going to use DezignWorks lock plane tool. What this allows us to do is to go into scan mode. We want to scan the center, and we're going to put a profile on it. In this case, it could be a spline or points. So we're going to grab this profile. What this allows you to do is pick a plane or multiple planes and drag it back and forth across the plane. In this case, it's the simplest form that we do this, is we're just going to create one cross-section and we're going to revolve it. So again, we're simply holding that button on the arm one time to press it and start scanning. You actually can go ahead and control the minimum distance that you want between points. In this case, we said 100 thousandths. You also can control where it trims to. So once you have enough, you can rotate the part to see, do you have enough data? And you can actually add more. So we're going to add a little bit more right in the middle here. The nice thing about this, it projects it all to a sketch, and you can modify and change it. So we actually have enough data there. So there's the profile for the hub of the impeller. So we're going to go ahead and use some of the SolidWorks tools. We're simply going to go ahead and just revolve this. That's why we created the origin around the center of the hub. Now we simply sketch some SolidWorks data. And the nice thing is you can mix and match all the tools together. So you can see we captured the profile with DezignWorks. We're capturing the sketch there. Now we're drawing with SolidWorks, kind of tracing down the center line. Now we'll just go ahead and revolve it. And there's our hub. So the next step we're going to do is utilize the 3D sketch in SolidWorks. What we're going to utilize is the fill surface. So we're first going to grab some boundary containment points. So we're going to start a 3D sketch, and we're going to use DezignWorks to take some points. Now these points are going to be inside of the boundary that we're going to use for the fill surface. The fill surface tool is like actually dropping a drape over a boundary with some control points. These control points actually pull the data down to the middle section of it. So we're going to grab these first, so I don't have to reorder it later. So we just take a few points and we finish it. So we capture the points with the arm and DezignWorks. Now we're going to go ahead and start another 3D sketch. And this is actually going to be the boundary. So we're going to go ahead and start another 3D sketch. And we're going to actually outline the blade. So across the top, it's fairly straight. We're going to create a line. And now we're going to go ahead and actually create a spline close to the edge of this. Now the heads-up display you see is we're pushing the buttons on the device to actually go grab that spline. So we're going to take some points along this edge. Now we'll probably go ahead and do the, there's a little line there, we'll do the line. And then there's one more spline on the other side. This can be done in several different ways. By doing this method, we can actually extend this a little nicer. So now we're going to grab the data close to the inside of the hub. So we're going to actually depress the button and drag the probe down through there and capture the other side. So now what we have our curves. So we're going to go ahead and lock down the lines, and then what we'll do, we'll pull that data from the splines into the lines there. So we'll go and use the constraint of SolidWorks and we'll fix those. Now we'll go ahead and we'll kind of put these ends together. And then we'll merge the endpoints. Just using normal SolidWorks tools. So again, we'll pick a point. And we'll go ahead and just merge these. And we'll do one more. So now we have them merged. Now what we're going to do is get out of the sketch. We're going to go ahead and use the fill surface. For some of you who don't know this tool, it's been around for a long time and it works great. So the boundary was the fill, and then the control points help pull this down. It actually makes the mathematics actually even more precise. So we're going to save our part now, and we're going to show you the validation tool with DezignWorks. Let's show you the accuracy of how this tool works, the fill surface. DezignWorks Professional allows you to validate your model during the reverse engineering process. So we can simply pick a face and take some points. And it'll generate a report. It's actually scary to see how accurate this fill surface is once you get some control points. We're holding 1,006/10. I mean, that's unbelievable. But again, that's the power of using SolidWorks and DezignWorks together. We're using the mathematics of the surface tools in SolidWorks and capturing it with DezignWorks. So now we're going to go ahead, we're going to go and actually extend that up to that hub. So we're going to extend that blade. And again, this is one of the reasons we did it the way we did. We can extend it by the edges. You can drag that around actually with the spline and get the same results. But with the method we did, we can control the extending better. So I've extended that. So we'll extend the other one too, because we're going to trim this a little later. We're going to trim this off. So now we have about 90% of this done. And if you notice, it's been less than 10 minutes. Now what we need to do, we need to trim the outside profile. So we're going to actually capture data on the blade and then actually convert it to a plane. So we're going to use DezignWorks to get this data on the edge of the blade, because we still have to trim this off out here. So we're taking points right on the edge of this blade. It's about 30 thousandths thick. We're using actually a point probe to capture this data. And we'll use that as our trimming data. So we're actually going to project that to a plane. And it's the best method we found to be able to trim this. So now that we have this, we're going to go ahead, that's the real edge. We'll build another surface, and then we'll use the SolidWorks surface tools to trim that edge off. So now we extended that original edge, and now we're going to trim it off. Have the blade trimmed to the outside profile. We're going to go and finish this up. So we're going to go ahead, trim it off, and now we're going to go ahead and give it some thickness. It's around 30 thousandths, we believe. Now we'll go ahead and simply revolve it. You simply pick the number of blades you want, and there you have it. You can see in under 10 minutes, we've created 90% of the blade. Tune in next week for more updates and parts on DezignWorks. Have a great day.